Hello, everyone. I just wanted to introduce my thoughts on the winter outlook for this upcoming season, mainly focused on the southern New England region. This forecast has been issued as of October. However, as of mid-November, I have made some edits just to encompass some new data that has come in. So when we take a look at last winter, this is basically what we see across the entire country. And as far as temperature goes, the eastern half of the United States really saw above normal temperatures, especially here in New England, where New England basically was right around 4 degrees above normal for the entire winter season. And I'm quantifying the entire winter season from November through March. And in terms of precipitation, here you can see on the left-hand image that outside of the leeward side of the Great Lakes up in New York State, much of New England as a whole really saw near normal amounts of precipitation, and that's just liquid precipitation. That doesn't necessarily account into snowfall. However, when we do look at snowfall, you can see for northern New England, they fared pretty well. Portions of far northern Maine end up getting anywhere between 120 to 180 inches of snowfall, and especially back through the Great Lakes, places like Buffalo and near Syracuse definitely got their fair share of snow with all of the heavy lake effect snowstorms that occurred during the early part of the winter season last year. However, near Boston actually saw one of the lowest winter seasons in terms of snowfall, only averaging about 12.5 inches of snow across the Boston metro area, and even lesser snowfall amounts as you go further south across Massachusetts, Connecticut, and Rhode Island. Now, across the Berkshires, especially in the higher elevations, they did quite well. They got upwards of 84 inches of snowfall, and even there were some reports of 90 to almost 100 inches of snow across far northern Worcester County, right across or near the New Hampshire border, where they also got their fair share of snowfall as well. But as a general aspect, it was a relatively snow-less winter across the southern portions of New England. When we take a look at the winter weather outlook for December, January, and February and what we can generally expect, here's the NOAA seasonal outlook for this year. And you can see here that there's generally a 40 to 50% chance at seeing above normal temperatures averaged across that entire 3-month time span. And in terms of precipitation, it's right around near normal. There may be a little bit of a increase of precipitation or a better chance at above normal precipitation across far southern New England, but that doesn't necessarily indicate if we're going to see above normal snowfall or just in terms of just general precipitation. So when we look at the 30-year climatological average in terms of snowfall, here's the 1981 through 2010 climatological map for snowfall. And even though now we have the 1991 through 2020 climatological average, this is still a pretty good representation of what locations can expect on any given winter here in New England. And you can see here, Boston usually averages about 48 inches of snowfall, with lesser snowfall amounts as you go further south across Connecticut and Rhode Island, and especially the Cape and the islands. But as you go up into northern New England, you get much more snowfall, which is typically what they see on any given year, and especially out for portions of the Great Lakes, given the lake effect snow machine that starts beginning in the month of October, going into November, and kind of tapering off as we get through January and February. Now, last year, we were in a La Nina pattern, and actually we were in a La Nina pattern for the last 3 winters. And La Nina, in general, usually bodes for a warmer than normal climate for southern New England, and it usually results in a little bit more mixed precipitation type events, especially for southern New England, including the Boston area and points south. But for northern New England, it usually does pretty well in terms of snowfall. Here's an average representation of what the jet stream looks like here. It's averaged in the blue arrow. Now, this is just a general idea of what a La Nina pattern looks like. However, that jet stream does wobble a little bit from week to week. So if we're on the colder side of that jet stream, then we can have a little bit more opportunities for cold and for snow. But if we're on the southern side of that jet stream, then we basically end up seeing warmer than normal temperatures and more mixed precipitation type events. Now, when we look at what's going on this year, It's the total opposite, where we're now in a El Nino type pattern, and actually we're in a moderately strong El Nino type pattern. And so this really has two modes. So the top mode here, this would be more indicative of a weaker La Nina. And I'm sorry, weaker El Nino. And so basically what you have here is you have these two positioning of two different jet streams. You have the northern jet and you also have the southern jet. And during a weak El Nino year, usually those two jet streams can interact with each other to create some pretty big potential snowstorm events across southern New England. It also allows for more opportunities for cold air to work its way further southward. However, during a strong El Nino year, those two jet streams are a little bit more displaced, where we end up being on the drier side of things. And since the northern jet stream is displaced a little bit further to our north, that means that the cold air trapped up in northern Canada, especially near the North Pole, is not necessarily allowed to dip further into the southern tier of the United States. And so this is really just one piece of the puzzle, because these jet streams, they can fluctuate on a week-to-week basis. So in order to really figure that out, we kind of have to figure out what is the jet stream going to look like, or what the jet stream may look like going into these winter months. And so the jet stream on average usually has two modes. It's usually a meridional jet, which is known as a little bit more of a wavy jet stream, or it's a little bit more of a zonal jet stream, where it's a little bit more flat. Well, the more wavy the jet stream is, the likelier it is to see more extremes, where we can have high pressure and warmer temperatures underneath the ridge, and in the trough, we can see more opportunities for low pressure and more opportunities for colder outbreaks. So the bigger the waviness in the jet, the more significant weather events you can have. And it's also important to know that that's not only across the United States, it's actually across the entire globe, especially here in the mid-latitudes of the northern hemisphere. So if you have a trough over New England, you essentially have a ridge of high pressure over the North Atlantic, which means you have a trough of low pressure somewhere over Europe, and so on and so forth. So it's more or less like a yin-yang effect. What occurs in one part of the world will affect another part of the world. And that's important when we're talking about what we may expect for this upcoming winter. Which leads us to the teleconnections. And the teleconnections do a very good job at dictating what the overall jet stream pattern may look like on a week-to-week basis. So these are large-scale pressure and circulation patterns that span vast parts of the earth. And so these teleconnections, they can be altered or influenced by sea surface temperatures in the tropics that are associated with El Nino and La Nina, and they can also indicate changes in the jet stream on a day to, or not day to day, but maybe several days or maybe several weeks. So there's four main teleconnections that can affect the US. And so the first one is the Arctic Oscillation, or the AO for short. Essentially, when it's in a positive state, the westerlies, which is our jet stream winds, they're a little bit stronger than normal. And so it helps to keep that cold, or the polar vortex, a little bit more behaved by keeping all that cold air locked a little bit closer to the Arctic Circle. However, when the AO is negative, it usually helps those westerlies become a little bit weaker than normal. So it allows the polar vortex to have more opportunities to sink southward into the lower 48 portion of the United States. The EPO is similar, where you have differences between trough of low pressure over the Gulf of Alaska, or a ridge of high pressure over the Gulf of Alaska, depending on the phase. If it's in a positive phase, then essentially what happens is that you have this trough of low pressure somewhere over the Gulf of Alaska. This is known as the Aleutian Low, and it basically allows for the jet stream to be a little bit more rigid over much of the continental United States, which would lead to warmer and drier conditions. However, if it's in a negative phase, then it's the polar opposite, where we have more ridging over the Gulf of Alaska, so warmer than normal and drier than normal weather, and we have more opportunities for Arctic cold, and especially more opportunities for storm systems to develop out in the rest of the continental United States. So as you can see, the EPO and the AO, they essentially complement each other. Now the NAO, the North Atlantic Oscillation, this is basically a mode where in its positive phase you have high pressure centered somewhere over Bermuda, and it allows more ridging over the eastern US, which leads to drier weather and also warmer than normal temperatures. However, during its negative phase, you can see here that that high pressure system is centered a little bit more over Greenland, so that allows colder shots of air to work its way down into the eastern part of the US and also allows for more opportunities for storm systems to develop. Now, the PNA, or the Pacific North American Oscillation, it's basically like the NAO, except it's just the West Coast version, where during a positive phase, you basically have warmer than normal and drier than normal conditions over the western US, and you have colder than normal and more opportunities for storm systems over the east. During a negative phase, it's basically the opposite, more troughiness and cooler weather and opportunities for low pressure systems over the west, and drier and warmer in the east. So if you really wanted a cold and snowy New England winter, especially one that's more above normal, you would want your winter months to feature a more positive PNA, a negative NAO, a negative AO, and a negative EPO. Well, El Nino and La Nina, they can help dictate what the general theme of these teleconnections may or may not do. So what we can do is we can kind of look at the current state of ENSO, and we can look at what it may do over the next several months. So here you can see that we're very much in a strong or relatively strong El Nino period. Now there was some discrepancy, especially over the summer months, on how strong El Nino was going to be, especially this winter, because here you can see in the graph, these are all the different models and all of the different indications of how these models think El Nino is going to behave this winter. But when you actually look at the current sea surface temperatures, especially in the equatorial Pacific where El Nino is, then you can see that the sea surface temperatures have started to cool off just slightly, not a tremendous amount, but just slightly, especially over the last few weeks. So it looks a little bit more indicative that it's going to be a moderately strong El Nino compared to a super El Nino, which a super El Nino would be really anything above 2 degrees above normal in the central equatorial Pacific. So what we can do is we can look at other years that transitioned quickly from La Nina to an El Nino that happened this year. And so these are analog years. These are years where we can kind of lean more towards to see the similarities and differences between what may occur this year compared to these previous years. And so some of these anomaly years are a little bit better than others, but all of these years here are basically years where we transitioned out from either La Nina or a neutral phase into a moderately strong El Nino year, where 1957 through 1958 and 1965 through 1966 seem to be the best comparison. And we do this in meteorology to essentially see what happened back then, because weather events tend to repeat themselves in some way, shape, or form. So this kind of gives us some idea of what happened back then and what we can expect for this season. When you look at all of those analog years for the months of December through February, this is what the average jet stream pattern looked like, where we had a little bit more of ridging over the Alberta region of Canada, so warmer and drier than normal conditions over the western portion of the United States, and we had more opportunities for low pressure systems to develop in the Ohio and Tennessee valleys as they tracked off the mid-Atlantic coast and just south of southern New England. When you look at all these years and you kind of dig down into the data, they basically featured anywhere between 0 to 2 1-foot plus snowstorms across all of those 8 anomaly years. In hindsight, there were more instances of smaller events that added up over time over a smaller season. For instance, Boston could get 8 inches of snow one week and then maybe 4 inches of snow another week, and then maybe another 10-foot snowstorm one week and maybe another 3-inch event and a 4-inch event, and so on and so forth. When you look at the average sea level pressure anomaly across all of those analog years, here you can see where the averaged area of low pressure was. And you can see how it basically just develops off of the mid-Atlantic coastline, more off the Delmarva, and basically scoots off into the North Atlantic. However, this is just the average track, and so this is not going to be fixed in place across the entire winter season. Note that this low pressure system, or the average of this, if it shifts just maybe 100 miles northward, that could pose some big storms and some big nor'easters for us here in southern New England. However, if it basically stays a little bit further south, then we can see less precipitation and less snowfall across southern New England, a little bit more cold, but it would be a little bit drier. So this would feature a little bit more close calls. But again, this is just an idea and an average of what we can expect this year. So I think in hindsight, there would be a lot of close calls or maybe even storms to watch, and we'll just have to see if they affect our area. Remember, this all depends on the jet stream, and that jet stream varies from week to week. When you look at snowfall, comparing those similar El Nino years for the Boston area and for the Worcester area, you can see that on a 30-year average, Boston averages about 48.6 inches of snowfall. Obviously, some years are more than others, some years are less than that. But when you look at all of these analog years, you can see that Boston averages right around 38 inches, which is fairly close to the climatological average. That's really just one snowstorm away from being tied to what the climatological average is. So here you can see it's slightly below normal, but more so near normal in hindsight for the Boston area. And it's basically the same thing. It's right around average for the Worcester area as well. And when you look at Western Massachusetts, especially the Berkshires, it's a little bit of a mixed bag because of where you are in the Berkshires. Topography plays a huge role in snowfall amounts, but on average, it's usually a little bit more near to slightly above normal in terms of snowfall, both for the Berkshires and pretty much the same thing for the Springfield area. When you look at all those anomaly years in terms of temperature, you can see how New England is basically right around normal, maybe even slightly below normal. And when we look at what the long-range seasonal models indicate in terms of just overall storm track, here is just what the jet stream looks like for the months of December, January, and February. This is the European seasonal model, and here you can see we have that ridge out in the Alberta region of Canada, or more so over the western part of the United States, and we have a little bit more of a dip in the jet stream across the central U.S., where the storm track basically follows these lines where storm systems would basically develop and track off of the mid-Atlantic somewhere. When you look at the Canadian seasonal model is basically indicating the same idea. Now, the Canadian seasonal model is usually about 33% correct, meaning to say that it's 33% of the time correct, the other 33 is incorrect, and then the other third of the time it's really no better than the climatological average. Whereas the European seasonal outlook has a 67% correctness track record. So it's about a D student, if you will. So about 67% of the time this forecast verifies correctly. So take these models with a grain of salt. It's just an idea of what we may experience for this upcoming winter. When we look at the teleconnections, this is the North Atlantic Oscillation, or the NAO. And just to keep things short and sweet here, I've basically circled colder signals in blue and warmer signals in red. And for December, February, and March, it all signs to a colder signal, but January signs to a more warm signal. For the PNA, it's a warmer signal in December and January, and colder in February and March. So here you can see that December, in terms of the NAO and the PNA, because remember they complement each other, they're both signaling a warmer December, but it's a little bit of a mixed bag for January, and they're both signaling cold for February and March. When we look at the AO, again, the AO is also signaling a warmer December, but also a warmer January, and maybe even a colder February, and March is right around near normal. And then when we look at the EPO, it's a colder December, around a neutral January, and it looks like a little bit more in terms of above normal for February, and perhaps maybe going into March. So here you can see there's a lot of mixed messages here in terms of the teleconnections on what we can actually expect. When we look at what happened, especially in the winters of 1957 through 1958 and 65 through 66, you can see here that there were warmer periods of the NAO, especially in December, and then colder periods as we went in through the months of January and into February. Going and taking a look at the PNA, warmer periods in December, and then near neutral in terms of teleconnections in terms of a positive or negative phase through January and going into February. For the AO, you can see here that there were warmer periods in December, but colder periods in January and February. And then we can see warmer periods in December in the EPO. And then there were spurts of colder periods at the end of January going into February. Another thing that we can look at is the Siberian snow and ice coverage, and that may lead to signals of what we can expect for the upcoming winter. Essentially, if there's more snow cover in the Siberian region in the months of October and November, then that basically leads to higher snowfall years and obviously means a little bit colder weather. Whereas if the Siberian snow cover is a little bit less in the months of October and November, then it usually leads to lower snow cover years. And when we take a look at what the anomalies were for the middle of October, here you can see in the dark red that this year we were well below normal in terms of snow extent across the far northern part of the northern hemisphere. Here you can see some other years where I've highlighted in the yellow arrow was the winter of 2014 through 2015, where Boston saw about 100 inches of snowfall. It was also known as Snowmageddon across much of the Northeast. And the winter of 13 through 14 was also very active with above normal snowfall and more shots of cold air. So here you can see that those years were very much above normal, where this year we're very much below normal. However, for the November update, here you can see that the snow and ice coverage is actually picked up speed a little bit in terms of how much snow and ice coverage is actually covering North America. And even though it was lacking in the middle of October, it's quickly decided to pick up the pace here in the middle portion of November. Right now, we're really just in the middle of the pack. I show this because there's a 75% correlation between snow and ice coverage and New England winter. So if we're above normal in terms of snow and ice coverage in Siberia, it leads to a snowier and colder winter here in southern New England. Some other considerations is that over the last 70 years or so, this has actually been the wettest summer that we've ever had, especially in the Boston area for the months of June, July, and August, totaling upwards of 20 inches of rainfall. When you look at what occurred during the top 10 wettest summers in the Boston area over the last 70 years, and you look at what happened in terms of snowfall the following year, we ended up about having 33 inches more or less of snowfall. And when you look at the top 10 snowless winters, it was also a very snowless winter. And over the last 70 years, we placed third as of having less snowfall, especially last year, with only about 12.5 inches of snowfall. Well, when you do the math and you look at what happened the following season, we averaged about 50 inches of snowfall, so slightly above normal, which is about a 200% increase from the previous year. And when you look at the Worcester area, it's basically the same thing, where over the last 70 years, it was an extremely wet summer, and the Worcester area in central Mass usually averages about 58 inches of snowfall for the following season. And when we look at the top 10 snowless winters, this is basically what the Worcester area gets. And you can see here it's right around 75.5 inches, more or less. So taking all that into consideration here, you can see that conditions look a little bit more like they're going to be near to perhaps maybe slightly above normal in terms of temperature, given the fact that this year has been relatively warmer in terms of global temperatures. That's why I'm leaning a little bit more on the warmer side. However, do note that we'll still have our shots of Arctic air across the entire winter season. In terms of snowfall, we're expecting near normal snowfall for Eastern Mass, Rhode Island, and Connecticut, with near to slightly above normal snowfall for central and western Mass, and basically the same thing for New York and for northern New England. Anywhere between 0 to 2 nor'easters, but it looks more likely that we'll see smaller events that add up over time. However, for those of you in the Boston area, compared to last winter and even the winter before that was rather snowless as well. Do note that this year, be prepared for instances of more snowfall compared to last year, and the even the year before that. And that may make you think that this is going to be a harsh winter, or it is a harsh winter, but in reality, it's a little bit more of an average winter season. So that's the outlook, in my opinion. If you have any questions, please feel free to reach out.